Chapter 2 The Periodic Table. Have you ever read stories from medieval times where a person called an alchemist tried to make gold? The alchemists were part scientist and part magician, and although they experimented with other forms of chemistry, they are famous for trying to make gold. They boiled up mixtures of every substance they could find: copper, tin, lead, iron, coal, silver, mercury, unusual rocks, gold-colored minerals, medicinal plants, parts of animals, and anything else they could think of. They even said magic spells over their boiling pots, but they never produced a single drop of gold. What the alchemists did not know is that gold is one of the basic ingredients in the kitchen cupboard of the universe. They thought gold had a recipe like water or salt or sugar. But you can't make gold. It's a basic ingredient that comes naturally in the earth. The letter symbol for gold is Au. Ancient peoples called gold by the name Arum, and that is where we get the letters Au. Can you find gold in the kitchen cupboard of the universe? The confusion of the alchemist is very understandable. Metals don't come with labels on them telling you what they're made of. Bronze and copper were both metals. Bronze could be melted down into two ingredients, copper and tin. The alchemists wondered why gold couldn't be boiled down to its ingredients. They didn't know that copper, like gold, is an element. It was only after years of experimenting that scientists began a list of substances they believed could not be reduced down any further. During the 300 years between 1200 AD and 1500 AD, the list of substances believed to be basic ingredients of the universe grew to include carbon, sulfur, iron, copper, silver, tin, mercury, lead, arsenic, antimony, bismuth, zinc, platinum, and gold. The alchemists eventually had to give up and admit that gold had no recipe. All of these elements are in our kitchen cupboard of the universe, though they are not sitting in a row. Several hundred years went by with no new discoveries of any more basic ingredients. Then, in the 1700s, chemists really began to catch on to the idea of elements, and they began intentionally looking for them. They were able to add many more substances to the list of basic elements, including hydrogen, oxygen, nitrogen, magnesium, chlorine, cobalt, nickel, bismuth, platinum, and tungsten. In many cases, chemists had not yet been able to produce these substances in a pure form, but they were still pretty sure that these things were basic ingredients, not mixtures. The chemists now began calling these basic ingredients elements. And by the year 1800, the official list of elements also included phosphorus, fluorine, barium, and strontium. Molybdenum, zirconium, chromium, and uranium. These elements were still very mysterious, however, and little was known about them. The list kept growing during the 1800s, and by the middle of the century there were over 60 elements on the list. But now there was no confusion about what an element was. Scientists understood very clearly that elements were the basic ingredients of the universe. An element could not be boiled down into anything else. They also understood there was probably a limited number of elements, and once they were all found, the fun of discovery would be over. Thus there ensued a sort of international scavenger hunt for new elements, with every chemist dreaming of being one of the lucky winners who would find one of the remaining unknown elements. Amidst all this frenzy for discovering the remaining elements, a Russian chemist named Dmitry Mendeleev began giving chemistry lectures at St. Petersburg University in 1867. As Mendeleev studied in order to prepare for his lectures, he began to have the feeling that the world of chemistry was like a huge forest in which you could easily get lost. There were no trails or maps, and there were so many trees. It was all a muddled mess of elements, mixtures, oxides, salts, acids, bases, gases, liquids, crystals, metals, and so much more. The subject of chemistry was confusing to his students, and he could see why. There was no overall structure to this area of science. It was just a massive collection of facts and observations about individual substances. Each scientist had a different way of arranging the substances, and that confused students. Some scientists grouped all the gases together, while others grouped them by color or listed them from most to least common or even alphabetically. Was one arrangement better than all the rest? Mendeleev decided he would search for some kind of overall pattern that could be applied to chemistry, making it easier for students to learn. Mendeleev began by cutting 63 squares of cardboard, one for each of the elements that were known at the time. On each he wrote the name of an element and its characteristics, whether it was solid, liquid, or gas, what color it was, how shiny it was, how much it weighed, how it reacted to other elements. He laid out the cards in various ways, trying to find an overall pattern. One evening he was sitting as usual in front of his element cards, staring at them and trying to think of some new way to arrange them. He had been working on this puzzle for 3 days straight, without any sleep. Mendeleev was exhausted as he fell asleep that night. While he slept, he dreamed about the cards. In his dream, he saw the cards line up into rows and columns, creating a rectangular table. When he woke up, he realized that his brain had solved the problem while he slept. The way to arrange the elements was first by weight, then by chemical properties. He began by laying out the elements in order of their weight, starting with the lightest, hydrogen. Then came helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. The next element was sodium. Instead of putting it next to fluorine, he put it beneath lithium because it had similar chemical properties to lithium. So the second line began with sodium. Then he began filling in with the elements arranged by weight again: magnesium, aluminum, silicon, phosphorus, sulfur, and chlorine. When he got to the next element, potassium, he decided to start a third line, putting potassium right underneath sodium, because they each had similar properties. Then it was back to listing them by weight: calcium, titanium, vanadium, chromium. As he laid the cards out in order of their weight, every once in a while he had to go back and start a new row so the elements that had similar chemical properties would be in the same column. This method of arranging the elements became known as the periodic table, because it is a table or chart that has patterns that repeat periodically. This is how the main part of Mendeleev's chart looked. Mendeleev ran into some problems with his periodic table. It seemed there were awkward areas where things did not fit perfectly. He guessed this was because there were cards missing. His set of 63 cards must be incomplete. Mendeleev began leaving blank spaces in his chart where he believed there was a missing element. He began to predict what these elements would be like when they were discovered. He even gave them temporary names. The empty space under boron and aluminum he named ekaboron. Eka means one more in the Sanskrit language. The empty space under carbon, silicon, and titanium was ekasilicon. Many chemists of Mendeleev's day laughed at him for trying to predict the discovery of new elements. They did not believe in his periodic table, and thought he was a fool for making up all these fictional elements that did not even exist. In 1875, one of Mendeleev's predictions came true. An element was discovered by a French chemist with a long name, Paul-Émile Lecoq de Boisdobron. He had decided to name this new element after his country, France, but using a very old word for France, gall. He named the element gallium. Mendeleev listened to the description of this new element and proudly announced that gallium was, in fact, the missing element he had called eka-aluminum. Mendeleev had already known what this element would be like. It would be a soft, silvery blue metal with very low melting point, so low that this metal might even melt in your hand. This is exactly how Bois de Broglie described gallium. Some chemists thought this was a coincidence and waited to see if any more of Mendelev's predictions would come true. After the discovery of gallium, Mendeleev became braver about making predictions. He announced that sometime soon a scientist would discover a new element that would be a very dark gray metal with a weight that was 72 times heavier than hydrogen, a specific gravity of about 5.5, and having the ability to combine with oxygen to make oxide compounds that are very hard to melt even in a hot fire. 15 years after this prediction, a scientist in Germany discovered a new metal that he named germanium, after Germany, of course. As you might guess, the characteristics of this new metal were exactly what Mendeleev had predicted. The scientific world was stunned as they compared Mendeleev's predictions with the actual experiment results for this new metal. They were almost identical. Germanium was Mendeleev's ecosilicon. Mendeleev was happy to have a real name for his ecosilicon and gladly replaced it with germanium. Eventually, Mendeleev and his periodic table became famous all over the world. He received gold medals and honorary degrees from universities in other countries, and was invited to join in important scientific societies. Sadly, however, his homeland of Russia refused to acknowledge him. When his name was presented to the Russian Academy of Sciences, he was rejected. Mendeleev was unpopular in Russia because he said things the Russian government did not want to hear. He told them they needed to be careful with Russia's supply of crude oil because it was a precious resource and would not last forever. He said that Russia's technology was lagging behind that of other nations and they needed to catch up. Sadly, the government didn't really care about improving the country, and they ignored Mendeleev's advice. After Mendeleev, chemists continued to discover elements. Every time a new element was discovered, it was added to the periodic table. The number of elements grew from 63 to over 100. Some adjustments had to be made to Mendeleev's original table in order to accommodate all the new discoveries. They added a middle section plus 2 rows at the bottom. Many decades after Mendeleev's death, scientists realized that there was nothing on the periodic table to commemorate the very man who had created it. So in 1955, when a new element was discovered, the discoverers decided to honor the memory of Dmitry Mendeleev by naming the new element Mendelevium. It is number 101 on the periodic table, and its letter symbol is MTD. To be fair, we really should mention that Mendeleev wasn't the only person who saw repeating patterns in the elements. A chemist named John Newlands had noticed this in the mid-1800s and published what he called the Law of Octaves in 1864, just a few years before Mendeleev's discovery. Previously, chemists had noticed groups of threes that behaved similarly and called them triads. For example, lithium, sodium, and potassium in the first column all reacted violently in water. Newland suggested that the triads were part of a larger pattern based on a number 8. He also suggested that atomic weights were a key to organizing the elements. Newlands turned out to be right about both. However, when Newlands presented his theory at the Royal Chemistry Society in London, they laughed at him and even made fun of him. They told him to go play chemistry on a piano. Unfortunately, this type of thing happens often. New theories that don't fit with current opinions are often scorned or even ridiculed. The Royal Chemistry Society did try to right this wrong in 1884 by asking Newlands to give a lecture at the Society. This time no one laughed at him. And today, if you go to the Royal Society of Chemistry website, they proudly suggest that the real discoverer of the periodic arrangement of elements was British, not Russian. In fact, they even placed a big blue sign on his birthplace, telling all who passed by that this is where the discoverer of the periodic table was born. Why did Mendeleev get credit and Newlands did not? Mendeleev's stroke of genius was to assume that all the elements had not been discovered, and to leave blank spots at points where the pattern seemed to fall. Newland's table did not leave blank spots for undiscovered elements, so it was bound to have problems in the end. Mendelev's table was not perfect either, but it was enough better than Newland's that Mendeleev is remembered as the inventor of the periodic table.